employees are, or half of you? Okay, great. Okay, so I work at Untitled, and we've been using StackViews within our new app that we're developing. So I'll tell you a little bit about the details of this new view. Some history. So before 2012, to lay out our apps, we used auto-resizing masks, and that's the springs and struts thing. I'm sure some of you can remember making apps with these springs and struts, and it was great while, before the new sizes of devices came out. But so in 2012, at WWDC in 2012, with iOS 6, Apple brought out auto layout, which was promising, to produce constraints on the views within your app, so that you could handle a variety of different sizes and rotations and within your app. So I'm sure you can remember back then too. It was quite new then, and people were struggling with the layouts of their apps up to that point. 2014, Apple introduced size classes, and this was all to lay the groundwork to come for the new iPad, etc. this year. So you can see the sort of evolution that Apple has brought about to enable basically multitasking on the iPad. And the size classes are defined just two size classes, regular and compact. So it wasn't it's not too difficult to implement these. Okay, so again, with all the different device sizes, we're forced to create layouts that can adapt to different sizes, and Apple may be producing new devices next year, which may have completely different dimensions, different aspect ratios, and resolutions even. So we have to be able to adapt to these changes. And so, auto layout, while quite powerful, I think a lot of people have been banging their head against their desk with auto layout. It's difficult to create layouts that work in all different sizes, and sometimes you've got a situation where you're trying to pour 10 pounds of potatoes into a 5-pound bag, and it just doesn't work. So Apple this year introduced a new view called the StackView, and you can see how much pain the Apple developers were to that point, because everyone was applauding this. This is like a huge development in layout for apps for iOS developers. So that was a very, very welcome development. What is a StackView? Well, simply a StackView just takes two or more views and stacks them either vertically or horizontally. It's a very simple concept. It's just a container view, and you can and this view doesn't actually have doesn't have to draw its own background. It's just simply there for laying out other views. It's kind of like a container view, and the views that it uses, which are laid out within it, are called arranged subviews. So not to be confused with normal subviews. A stack view can actually just take a subview, but it won't be rendered. So it has to be put in as an arranged subview, and then the constraints within the stack view come to life. Okay. So on iOS it's called UIStackView, on macOS it's NSStackView. So if you look at layouts within your app, you can probably think of a way to arrange them either vertically or horizontally, or a mixture of those two. So the power of StackView is actually you can nest vertical and horizontal views within each other. So you can have a very composed structure of a stack view. And you can probably lay out the vast majority of apps this way. Okay, at WWDC this year, the promises were made that StackView is easy to build, easy to maintain because you have to worry about less constraints. Composable, that means that you can nest these things, what I just talked about, and very lightweight. So again, the StackView doesn't draw its own background. It's made very fast and performant, and those are the promises made by specifically Jason Yao, who is an IB interface builder engineer at Apple. And he says, we feel that you can build most of your user faces with StackViews. So we recommend starting with stack views and using constraints as needed. So this is Apple's push towards developers. Use Interface Builder, start with stack views, and only if stack views alone don't work, then start introducing additional constraints. So this is the promise that Apple's making to developers. Whether that actually is currently possible, I'll talk about later. But that was the push from Apple this year. So stack views, no visible appearance, so you can't give it a background color. It's just there to do one thing, and that's laying out the views within it, the arranged subviews within it. It does this mainly by using the intrinsic content sizes of the arranged subviews. So the intrinsic content size is a really important concept to get one's head around when dealing with stack views. Nearly all of the stack views use this intrinsic content size. Some of them break it to a certain extent to get the layout that you need, but it's really a really crucial component of a stack view. Stack views have two dimensions, and they call them axes. So you have the horizontal axis and the vertical axis. And then you have additional properties which are called alignment, distribution, and spacing. I'll quickly go over them first and then go over them in much more detail. So first, alignment. The alignment shows how the subviews, the arranged subviews, are arranged perpendicular to the axis. So it's a vertical stack view. It arranges these horizontally along that axis. And for horizontal stack views, it's the vertical arrangement. Yeah? So you have a quick summary there of the alignment property. Distribution. Now this is a little bit more difficult to get one's head around, but it's simply how the arranged subviews are arranged along the axis of the stack view. So you have fill equally, equal spacing, and equal centering as the main distribution patterns for the stack view. And then you have spacing, and this is the minimum distance in points between the adjacent edges of the stack view's arranged views. In the first image there you have a larger spacing, and in the other you have zero spacing. So this is another one of the properties. Let's look at these in much more, we'll first do this. Okay, so you have the stack view, and the stack view takes care of the arranged subviews, layout constraints within it. However, you still have to define the constraints to its super view. So if you've got the stack view in a view controller's view, you still have to lay out, the manual constraints to the super view. And often you only want to lay out two or three of them so that the stack view can grow depending on the arranged subview's intrinsic size. So in this case, I've constrained them to all four sides. So you can see the top and the bottom constraints and the leading and trailing constraints of the stack view to the containing super view. Okay, let's have a look at some detailed examples of some fun Disney pics. So I just dragged out 4 Disney images onto the storyboard in Interface Builder. Then there's a button which is called Embed in Stack View, and this is the result you get when you do that. Now it looks like the stack view has a background, it's just that there in Interface Builder it does not render when you actually run the app. And then the default properties of the stack view are called alignment fill, distribution fill, and zero spacing. And this is how it looks when you do that. Okay, so let's look at the alignment, the UIStackView alignment top property. As you can see, I've got a red line just to show you the alignment. This property enum is at the top, so all the subviews are pushed to the top of the view. And then you have center and bottom. Very simple. So flying through these slides. So even though there's 40 slides, we'll get through them very quickly. Okay. There's another one which is quite interesting. A UIStackView alignment first baseline. Now this aligns all the arranged subviews so that the first baseline of their content is in one line, which is only available for horizontal stacks, but really useful, I think, if you've got a very text-based app. because it gives you a very nice sort of arrangement there of the views. And the same goes for the last baseline. So again, only available on horizontal stacks, but something that I think a lot of people may find really, really useful and quite hard to do if you were to do it with using manual auto layout constraints. Okay, one note which is quite useful, I made a few mistakes with this when I first started. The baseline alignment only works on views whose height matches their intrinsic content size's height. So if the view is stretched or compressed, you will not get the right result. So always use the standard intrinsic sizing for your text-based views to get the right effect. Okay, so looking more towards some of the details of these alignments and distributions settings. They can be sometimes quite difficult to understand exactly what's going on, and if there's ambiguity, how the stack view resolves them is quite interesting. So here you have UIStackView alignment fill, and this actually does not use the intrinsic content sizes of the subviews. They simply fill the space, so it just stretches them out to fill the whole stack view itself. Okay, again you have the leading edge, the center, and the trailing. And this, to the furthest ability of the stack view, will still maintain the intrinsic content size of the subviews. Okay, now with distribution, which is a little bit more difficult. So for horizontal and vertical views, stack views, it will fill the available space along its axis. So you can see in the first image that the Mickey Mouse image is kind of stretched out, but the others actually are at their correct aspect ratios. And in the vertical stack view on the right, because the subview's intrinsic sizes are, their total height is bigger than the stack view containing the container itself, has to compress one or more of them. And you can see that Mickey Mouse is kind of slightly compressed, slightly squashed at the top. And I'll talk about why the stack view does that in a minute. First though, I have to talk a little bit about this content hugging, compression resistant priorities of certain views. So basically a view with an intrinsic content size creates constraints based on that property of itself. And its content hugging priority determines how much it resists growing larger than its intrinsic size. So it will tell you, how much does it hug the corners of its view. And the higher the priority, the more it will try not to be stretched out. This is really important when dealing with unwanted compression, unwanted stretching of the view. Well, basically, it's an inequality constraint saying that the view size should be smaller or equal to its intrinsic size. And the default priority is usually around 250. Sometimes when you drag these views onto Interface Builder, it gives it like a number of 251, and that's for trying to get rid of some ambiguity, or if there's a conflict between the views, it will always take the larger priority first. Any priority below 1000 is optional, so these are not necessary to be observed by the layout system, but the higher the number, the more chance it has of being used within the layout pass when it's rendered. And then we talk about the compression resistant priorities. That's the content compression resistance priority along each axis. So you have two numbers there, one for horizontal, one for vertical, for both of these concepts. And that determines the resistance to shrinking smaller than its size. So the higher the priority, the more it will try not to be squashed. In effect, it's an inequality constraint saying that the view size should be larger or equal to its intrinsic size. And the default priority is around 750. That shows you that views are more likely to be stretched than they are to be compressed because of the 750 versus 250 number. Okay, so here I've just pulled out 4 labels onto the to a storyboard and put them in a stack view, and using I think the standard settings of a stack view, because I didn't actually play around with the numbers at all. And you can see on the first case, the red label is stretched out completely. And that might be a bit confusing to realize why, but basically if there's an ambiguity as to which one should be stretched, it's going to stretch out the one with the lowest content hugging priority. However, they all have a content hugging priority of 251 when they were dragged out. So it will start with the index 0 of the views within the stack view. That's the first view that you've dragged out, and then it will use that one first to stretch. So that's why you have the red one being stretched out first onto the stack view. However, if I reduce, so if I increase the content hugging priority of the red view, then it goes to the next one, say, okay, which one of your other ones shall I stretch? And it says, well, the yellow one, the green one, and the orange one have all content hugging priorities of 251. So which one shall I take? Well, I'll just take the first one of the rest. So it's the yellow one that's then stretched out. So going back to the one that I spoke about, the one with the distribution, fill distribution of the stack view, Mickey is stretched because even though it has the same CH priority as the others, it's the first one. And the same for when the views do not fit in the stack view, it will compress it on the right. So you can see the ones that are stretched and squashed in these cases. Then we have, okay, to talk a little bit more detail about the distribution fill equally arrangement. I've added here a little bit of spacing to make it more obvious what's going on. The layout resizes the arranged views so that they fill the available space along the stack view's axis, and they resize so that they're the same size. So that's quite a nice arrangement, but there is a lot of squashing going on with each of these images in this case. So it's not one I would use for, obviously, for this actual view. And fill proportionally, well, it does use the intrinsic content size a little bit, and it does its best to lay them out, observing the actual aspect ratio of these images. Not the aspect ratio, but their proportional heights in this case. And here we have distribution equal spacing. So this is also quite interesting. They try to fill the available space, but still observing the spacing property. And they try and do it as evenly as possible. If there's any ambiguity, they shrink the views based on the index in the arranged subviews array, which is how they've been put into the stack view in the first place. So if they cannot fit, then that's what it does. It stretches them, and if they cannot fill, that means they stretch them. If they cannot fit, if they're too big, the views, then you compress one of them or more of them to try and achieve this effect. And then equal centering, also quite a nice, I think, way of laying out a screen depending on what you're trying to do. This would be very difficult to do with manual layout constraints, so this is a really nice effect for a lot of, I think, apps to use. And again, the details are very similar in terms of how does the system decide which ones to compress, which ones to stretch. And this sort of very simple rules-based approach to choosing what should happen to the views. And just to quickly see, a quick picture of all 5 of these properties for the distribution arrangement in this case. With some code. So if you want to do this, it's all can be done in code too, and sometimes it's better, I think, to do things in code because Interface Builder does a lot of sometimes magic behind the scenes. It's quite difficult to debug some of these interfaces in Interface Builder. So if you just, so what I've done here, I've just thrown it into a view controller. I've created the views and given them variable names. And you can see, one thing that if you do it programmatically, to make sure you translate auto-resizing mask into constraints to false. This is because of the legacy issue I talked about right at the beginning. Apps use auto-resizing masks to lay themselves out. You really do want to set that to false, otherwise you will have ambiguous constraints placed into the system. Then all you have to do is add the stack view to the view, and at the bottom you can see that I've had to make the constraints manually for that. But other than that, all you have to say is Disney stack add the range subview for each of the subviews, and put some of the properties on the stack view. So horizontal axis, center alignment, equal spacing at 0, and the spacing to be 0, because the app will decide on its spacing automatically. So to get the right view, that's what I had to do. This is also quite useful. You can actually put a layer, well, you can put some padding around your stack view by using the layout margins relative arrangement property. And it's by default it's 0 or false. And I've used that. I think in this case, I've basically put a left and right margin onto this view, into the stack view, so it doesn't touch the edge of the screen. You can also use, of course, the layout margins and the layout guides from the view to the window view, and that's also a way of doing it. But this is quite useful too. Okay, you can also do a lot of things with the stack view in terms of hiding the arranged subviews, and you can also animate these changes quite easily. So what I've done here is I've got a horizontal stack view, and it's composed of small vertical stack views. The vertical stack views are just the label and the image. So I'm going to, that hide Pluto button is actually an external, has external constraints to the stack view. So you can actually put external constraints on the stack view too, which is quite useful. And if I hit that hide Pluto button, it should get rid of the vertical stack view containing Pluto label and the Pluto image. So let's see if I can get that working. Oh, okay. I was about to see if I can get that. For some reason I can't control this video here. Sure why.
If you tap on the image, will it start? No?
No, it's just, okay. Well, it would have shown you the Pluto image kind of animate out as I hit the button and animate in again as I hit it again, so I have to work out how to use the thing probably. Okay, so you can, as I mentioned before, you can fine-tune the arranged views appearance by adding additional constraints, but that can sometimes be quite tricky because the stack view has its own internal constraints, and you're adding constraints on top of that, and that can sometimes create ambiguity. So Apple actually does have a rule of thumb. If the view size defaults back to its intrinsic content size for a given dimension, you can safely add a constraint for that dimension. But in practice, it's maybe a little bit more difficult to do. I've had quite some difficulties doing this with the stack view. Actually, constraining, say, the height or the width of views within the stack view manually works out usually quite well, but again, it depends on the alignment and distribution properties that you've set on the stack view. Okay, so well, we've been using stack views in the app that we're building, and theoretically, it all looks really easy. Like when you see the WWDC demo, it looks like magic. I mean, it really is fantastic. And I was like, wow, this is great. You know, this is going to really be great for our app. But trying to actually use it, there were quite a few bugs, especially when you're putting scroll views into the stack view. That's caused a lot of problems, and self-sizing cells. Mostly we've been able to get it to work though, but it does feel a little bit like a version 1 technology. I hope that Apple's going to really push forward and improve it. We have very high hopes for it. Another thing is it's great if you're just making your app work for iOS 9. It will not be supported on earlier versions, but some people are already making backports, and I think UIStackView is probably the front runner here, and it supports back to iOS 7. I've never used it, so I can't tell you how good it is. These are the sources I used for this presentation. Definitely watch the WWDC video, Mysteries of Auto Layout 1. It's really good, and the second one's also very good. If you're into actually making stack views programmatically, Max Newberg's book is great. I really recommend that. And also, if you're really a beginner, like I am, really into coding, like Simon Allardyce is a really good tutor. He's now on Pluralsight. He does some really good courses. And of course, the UIStackView class reference by Apple is a definitive guide to all things StackView. Okay, well, thank you very much. You can contact me anytime on my email. And if there's any questions, please let me know. Any questions?
UIStackView questions.
Great. Looks like I've covered everything.
I'm curious about your real life experience
Right.
with it. Like, what kind of scenarios have you run into that haven't met your expectations based on what you know about UIStack?
We've had some difficulties, like I said, with scroll views, putting them into especially a collection view, and sometimes also with table views, which have to size according to its content. But I think most of them were resolved eventually. At the beginning, though, it took us several days to sometimes get a view to work, so it was frustrating. But Matt, is there any cases where we couldn't get it to work at all?
The one case so we had a 3-level stack view. One was horizontal with an image and some content, and then this content was horizontal, this content was vertical, and then inside the vertical was another horizontal, inside of a collection view set, to be clear.
Okay.
And in that case, it was we were unable to get the image to not be oddly sized. Like the image should have kind of preserved its aspect ratio, but it was very difficult to get that to happen. So that's the one thing with UIKit is that there are many combinations of views that you use inside of another. Also, text views were a problem, I believe. Right? Or actually, text views were a problem in Interface Builder.
Yes,
It would actually crash Interface Builder when you wanted to put a text view inside of a stack view and then set it scrolling to false. The reason you need to set scrolling to false because then if scrolling is true in a text view, it's a scroll view, so actually the height is, it doesn't check its content to get the height, so then the stack view doesn't know what height to have it, because like, well, I can scroll it, so it doesn't matter what the height is. But if you do that in Interface Builder, it would crash it. So that was another case. But we ended up using constraints to do the image we had a 2-level stack view, and then we just used regular constraints for the image to the stack view, if I remember. So.
Does it make you wonder, I guess, after going through that, would it have been easier to have not used the stack view, or were there benefits of the stack view that you were able to take advantage of in your implementation?
Yeah, I think we did still want to actually prefer the stack view because it's very easy to remove the arranged subviews from it and animate those changes, and that's just really useful. Because usually if you remove a view or if you hide a view, you have to lay out all the constraints again, or for that case, and the stack view handles that really well. So overall, I think it's a net win.
Okay.
In some cases, though, we just couldn't get it to work. It's true.
So, sorry.
Please go ahead.
If it works well,
Yeah.
as expected, do you think it's gonna replace auto layout completely? Or
No, it will never be able to fully replace auto layout. You're always going to need auto layout for the cases where the stack view just can't. It's just not enough flexibility. I mean, the stack view is really good at laying out views either horizontally or vertically or in a nested fashion with a combination of those. But if you want to do anything else, I mean, you really do need to have manual constraints. But Apple's really saying, like, use the stack view first, and only if you really can't do what you need to do with stack view, then use layout constraints. And you'll always need layout constraints to the super view anyway, so it's never going to completely replace it. As far as I know, I think this technology has already been in Android since version 1. It's called linear layout. It's very similar. So, I think it's gone a long way on Android, and now Apple's trying to also do the multitasking with the multiple screen size, so it's the way to go.
I got an impression that it's gonna lower the threshold for like newcomers Like when they see auto layout, they are like,
I hope so, yeah.
Yeah.
Well, Apple's really trying to make it more user-friendly.
mm,
Like when I first saw auto layout a few years ago, like 2012, I thought, oh god, this is terrible. Right? And I didn't want to have to deal with all these new screen sizes. But they've come to, they're going to stay, and it's just going to get even more and more of them. So we have to learn how to deal with them.
Could I just make one comment as well? Like, it's also probably important to design for the stack view. Like if you're working with a designer and he gives you a design that is specified, such as like the distance between here is 8 pixels and the distance from here is 12 pixels and the distance from here to here is 16 pixels or whatever. You don't have that degree of control in a stack view. You could put them, vertically, but they're going to be spaced evenly. Sort of. There would be, in the most simple case. You could, for example, do, this is a stack view with 2 elements with another stack view inside of it with these. That would be one way to do it. And you could also do some things with the views. You could adjust the views internally to like create that spacing and things. You have ways of doing it, but that's also a little bit more complex. Yeah. But you would get the advantage of speed with a stack view if you actually approach the app thinking like this is going to be an app that uses a stack view. And so like if your designer is thinking in terms of numerical pixel spacing things, it would be better to think about, more like relative position and even spacing or equal spacing between elements and things like that. So I do think
it looks very similar to Apple Watch UI implementation. You put like container view and then you put elements in it, so it looks very similar.
But that would be the one thing if you want to really take advantage of a stack view. Think about it from the beginning and see if you can live with some of the limitations it provides in terms of like precision in your layout.
Yeah, what Matt says is very true. Like designers need to get on board with this and really know how these things work, because you can save a lot of time actually implementing the app if you use stack view. And if as a designer myself, background-wise, I thought, well, some of the views, I don't really care too much about certain things, and I care a lot about other things. So I think about, okay, can I use the stack view to do what I want to do? And then, if I do I really need this to be 12 pixels rather than 11, or 11 points rather than 12 points? Sometimes it's not that important. I can then use a stack view and go, okay, that'll save us a lot of time down the line. So it's a matter of like, design is always a compromise between different things, and designers can really benefit from really playing around in Interface Builder, I think, with their views, especially when it comes to, we're lucky that we don't have to worry about size classes at this point, but you could easily switch the axis of a stack view from vertical to horizontal and back again, and that was really great for size classing. Like, if you have a very a compact view, then you can maybe use a vertical stack view, and if you have a regular view, you can switch it to a horizontal stack view. Then it's just a very simple setting in the size class in Interface Builder or in code, and that way you can have a wide variety of different layouts that work on all different devices just by simply changing that one property of the stack view. So I really recommend using it, especially if you're dealing with lots of different sizes and aspect ratios in your app. Yes?
Can you bring the previous slide back, please?
Sure. This one?
Yeah.
Okay. Any other questions? Yeah.
So do you develop your app with purpose of using this stack view in your app?
Well, we did the designs previous to knowing about StackView, but then StackView came out and we had a look at it, and we were like, okay, we can do a lot of the things in StackView, but we'll just change the design a little bit to make it work.
Okay.
So because we're like, okay.
So it doesn't affect the previous iOS version that Max.
This is a new app we're making, so we don't have to worry, luckily, about iOS 8. So that's a good point. We're lucky in that we don't have to worry about previous versions of iOS. So if you're making a purely iOS 9 app, it's great. Yeah.
can you animate the content of your stack view into place? Like say you wanted each one to slide in individually.
Yes, absolutely. It's really easy to do because you can just add the arranged subviews to the stack view and just set their property to hidden, and then you can animate them into view just using a simple animation block, and it's just a few lines of code. It's really, really simple to do.
Okay.
Great. Thank you very much.